The purpose of this video is to talk to you about unstructured data mining, and in particular going through and looking at your data to see if there are underlying relationships with your data that you perhaps haven't ever considered before. Again, it's unstructured data mining because we don't really have any theory behind it. Instead, it really is just from that. It's almost like the descriptive analytics. We have data and we're just trying to find out a little bit of information about it. But again, no theory behind it. When you're thinking about the very first component of this data mining, there's a principal component analysis is one of the things that comes up. And principal component analysis is almost like trying to find linear relationships between different sets of variable. Okay, for example, if I say that agriculture has something to do with exports, you know from working with Excel in the past and whatever else, that you could go in and you could insert a scatter plot. And the scatter plot would say, if I have agriculture on one side, exports on the other, that we have this relationship that's kind of between these two variables. If I right-click on one of the data and I add a trend line, you can see that I now have this component. It says I'm trying to explain agriculture by exports or exports by agriculture. And so mathematically, what the computer is trying to do is it's trying to say, how can I establish a relationship by looking at each one of the data points, each one of these dots, and then it lays a line in here. It's decided that this is the perfect line, and the way that it knows mathematically that it's the perfect line is it has taken and calculated the distance between this data point and this line, and this data point and that line, and that data point and the line, and whatever else, and it takes and it sums up every one of these distances, puts a line in, adjusts the height of the line, and then also the slope of the line until it minimizes the total distance. At that point, it says, okay, you know what, that's our line. You can also go in, and we've done it before, you can add a relationship. And it says that now we have a relationship between agriculture and exports where there is if you take, in this case here, it looks like agriculture is on the Y value. Agriculture equals 0.4626 times whatever the value is for exports, plus an intercept. And then it gives us an R-squared value of 0.05, which means that we've only explained 5% of the variance. Mathematically, once again, all we're doing with components, we are going in and saying we don't know why there's a relationship. We don't even know if there really is a relationship. But could you draw in the first component? Now, what I just mentioned to you a few seconds ago was just looking at two variables. You can probably see that, or extrapolate here, that you could also do a line between exports and final consumption. So that could be another component. Or what happens if I take and list all three of those and try to create one line through all three of those at the same time? It starts getting really difficult for the human brain to be able to think about a line no longer in just an X and a Y axis, but also in an X and a Y and a Z. And it says that if I have an X, a Y, and a Z axis, where every one of these little data points are perfectly positioned based on where they are, with their values rather, that I could also draw a line in three-dimensional space. And at that point, that is another component. And what the component really is trying to say is I am trying to mathematically tell you what the relationships are between these things. And I'm trying to explain the variability with each one of these components. Now let's drag that even further. Let's take that all the way out to 5. And your brain has trouble trying to, or at least my brain has trouble coming up with thinking about things in three-dimensional space. If I go to 5-dimensional space, My brain can't handle it. Mathematically, though, the computer can easily handle it, and it can draw different lines between different variables and say which of these components matters the most to us. Okay, that's what's going on with principal component analysis. It is trying to draw these new lines to explain the most variance. It will draw the first line that will explain the most variance, and then it'll go to another line, then another line, so on, so on, so on. So what we are doing here with principal component analysis, I am going to go in, again, this is page 356 in your book. I'm going to go to data mining, and then whenever I get to data mining, I'm going to go to transform principal components. And in principal components, I want everything except for country as my selected variables. Again, all of these variables are going to be selected. Make sure that you are from A1 all the way down to F12 as your data. Let's make sure that we're not missing any other information here. Click on Next. We are going to use a correlation matrix instead of the covariance, so we're going to use correlation. And I believe it's also told us that we're going to use fixed number of components. And in this case here, we're going to keep it at 5. Go ahead and click Next. We want to show the principal component scores. And click on Finish. Okay. Output comes out and it says, here are some things for us to consider. First of all, the very first line that it draws through, or the very first component, is a line that explains 55% of the variance. Okay? The very first component explains 55% of the variance. And you're like, well, I don't even know what that line looks like. Well, it gives you the data above there in principal components. It says on principal component 1 that if I were doing a relationship and showing back again with my regression analysis, I am looking at y equals some beta value for agriculture, a beta value for agriculture, a beta value for exports, all the way through to the very end. And then it says here's the weight associated with each of these. So with component 1, the highest value is for the GDP per capita growth. And whenever I say highest, even though it's a negative value here, it's the highest in magnitude. Okay? So component 1, GDP per capita growth, 0.561 is the very top component. The next one. Next and most important is GDP growth at minus 0.560. Third most important, final consumption, minus 0.515. Okay, so component 1 is most heavily associated with GDP per capita, GDP growth, final consumption. All right, that takes care of 55% of our variance. If I add in component 2, okay, so if I have component 1 in and I add that second line for component 2, I can get up to 86% of all the variance. Well, which of the variables is associated with component 2? Well, these are the values for it. Component 2 is most associated with agriculture at minus 0.658 and with exports at minus 0.570 and with final consumption at 0.362. Again, the very first component was more concerned with these three variables. The second components were more concerned with these three variables. All right, so that means that to finish up the homework assignment, which says to list the top 3 variables, all right, and make sure we get up to 95%. If we go to the third component, we're going to go up to 97.5% of the variance, right? With component 3, what are the top 3 variables for component number 3? Well, they are minus 0.683 for agriculture, 0.649 for exports, and then 0.276 for GDP. All right, hopefully this helps you understand that what is going on right now with that principal component analysis, not only how to read the data, but it says that there really are, when I'm trying to look at these 5 variables, something that really matters, and we don't know what it is yet. This is data mining. Something's associated with these 3 variables, and it really does matter in being able to explain 55% of our the variance in this data set. And if I add another component, that other component has something more to do with agriculture exports, and final consumption. It adds another 31% to the variance. And then finally, if I go with a third component, agriculture, exports, and GDP per capita growth, they're related in some way that also helps us. We don't know that yet. It helps us just being able to look at these things and say, what variables out there, or what reasons would this matter? What reasons would this matter? What reasons would these 2 and that one matter? And that's what principal component analysis is doing for us. It's saying, let's look at all of the data, and then once I look at the data, let's consider how they possibly could be related together. Okay, hopefully this helps you get through the first part of the homework.